Good day, students. This is the second part of the CST review for Algebra 1. So I'm going to be starting from where I stopped. I'm going to be starting from question 21. So number 21, as you can see here, it says, which of the following is a valid conclusion to the statement if a student is a high school band member, then the student is a good musician? What is a valid conclusion? So if a student is a high school band member, if that automatically means that the student is a good musician, then we can say that all high school band members are a subset of good musicians. Since this automatically implies that, we can illustrate this with the use of a set. This set could be the high school band members. Okay, let me make that a little bit bigger. How about use circles here for my shapes? Circles. So let's see the first circle. That one right there is for high school band member. Okay. If someone is a high school band member, that automatically means the person is a good musician. So what this is telling us is that all high school band members are a subset of a bigger set, which is a set of good musicians. Okay, so the bigger set is a set of good musicians. We know that the high school band, a high school member is not the only. Everybody in the world is not a high school member, right? There are other people in the world that are not in the high school. So this is a bigger set. This is a set of good musicians. Okay, we have good musicians that are not in the high school, right? Because high school has age constraints to it. So we know that for this case, all high school band members are in the bigger subset of good musicians, because there are people here that are not high school band members, right? Because they already went to high school and they already graduated, but they are good musicians. Okay, so taking a look at this set notation and keeping in mind the fact that high school band members are a subset of a bigger set of good musicians, what can we conclude? It says all good musicians are high school band members. Is that the case? Absolutely not. As we said here, not every good musician is in high school. All right, some are in middle school, some have graduated, or a lot more have graduated. Okay, so A is no. A is false. How about B? A student is a high school band member. Not all the students are high school band members, because not all the students are good musicians, right? There's students that are not part of the band, so we can't say that a student is a high school band member. Okay, a student can be in soccer or other sports, so this is not a good conclusion. B is not. How about C? All students are good musicians. All students are good musicians doesn't apply here, because it's only the students that are high school band members that are good musicians. So the C option lacks the component of being a band member. Okay, so C is not a good option. So that leaves us with D. Let's take a look at this. It says all high school band members are good musicians. High school band members, are they all sitting in this bigger set of good musicians? Yes, they are. So the valid conclusion is D. Okay? Alright, let's move on to the next question. Question number 22. 22 says, the chart below shows an expression evaluated for 4 different values of x. Society concluded that for all positive values of x and x squared plus x plus 5 produces a prime number, which value of x serves as a counterexample to prove Josiah's conclusion as false? So, first thing we need to know is what are prime numbers? Prime numbers are divisible by themselves in just one, right? So the number is prime. It is divisible by 1 and itself only. Okay? There are no other numbers that are divisible by that number. Okay? So examples of prime, we have 2, 5. Oh, it's not right. I forgot. I left out 3. 2, 3, 5, 7, 9 is not prime because 3 goes into that. 11, 13, 17, 19, 23, 29, and the list goes on and on and on. Okay, these numbers are divisible by only 1 on themselves. Okay, no other number can go into them. Okay, so let's take a look at this chart. We see that these are prime numbers, but which of these inputs will show that the output is non-prime? So let's see. In order to do this, this is like a plug and chug type problem. We're going to have to pick a number to see if it works or it doesn't. Okay? So we have our x value here. 1, 2, 6, 7 are perfect because they produce primes. Alright, let's try our first option here. Okay, which is x equals 5. The question is, if I plug in 5 for x in the expression x squared plus x plus 5, will I get a prime number? Yes or no? If I get a prime number, then we have to check the next one to make sure one of these should generate a non-prime, and that will make our answer, that will be our answer. Okay, so let's start with 5 and plug it in. Alright, so the question is 5 squared, substitute 5 for x, 5 squared plus 5 plus 5. Is this a prime number? If I simplify this expression, will I get a prime number? Simplify this, we have 25 plus 5 plus 5. These are all multiples of 5, so the sum must be a multiple of 5, right? So if I add everything together, I'll have 35. Wait a minute, is there any number other than 1 and 35 that go into 35? Of course, because 5 goes into 35, right? 35 divided by 5 is 7. So 5 goes into 5 goes into 35. And also another number, 7 goes into 35 5 times, right? So guess what? This is not prime. So since we have an x value that produces a non-prime output, that means that Josiah's conclusion is false based on input A. Input A is x equals 5, because when I plugged it in, I did not get a prime number. Had I got something like 31, which is prime, then I have to go to B, check to see if it's prime. The one that gives me a non-prime, that is the answer. All right? Okay. Let's go ahead and look at number 23. It says, John's solution to the equation is shown below. Which property of real numbers did John use for step 2? So, multiplication property. Is it multiplication property of equality, zero product, commutative, or distributive property of multiplication over addition? So let's go over the properties real quick. So for A, the multiplication property of equality basically says that if A equals B, then A times C equals B times C, right? That's what the multiplication property of equality says. If I multiply something by both sides, I'll get exactly the same thing as I started with. But take a look at step 2 here. Is any multiplication happening? Absolutely not. Actually, the opposite is happening. It's being broken apart. Okay, so it's not A. Let's take a look at B. The zero product property says that if A times B equals 0, then A equals 0 or B equals 0. Okay, let me write down the names. This one is multiplication, okay? Multiplication property, and this one is zero product. Zero product, okay? So, is this what's happening here? X plus 2 times x plus 3 equals 3. Step 2 says x plus 2 equals 0 or x plus 3 equals 0. Are they being broken apart and set to 0 in step 2? Absolutely. So this is your answer, B. Okay? Let's take a look at C just for kicks. Commutative property basically means that you have A times B, basically is the same thing as B times A. Okay? And D, distributive property of multiplication over addition is basically saying that if you have A times A plus A times B plus C, simply means that the product on the outside can be distributed to the quantity on the inside. So this equals AB plus AC. Okay, A times B, A times C. We clearly see that these two do not apply to this problem here because stuff isn't getting commuted, and then here there's no distribution going on. All right, so our answer is B. Okay, let's move on to the next question, question 24. Um, it says, Stan's solution to an equation is shown below. Which statement about Stan's solution is true? So the first one says Stan's solution is correct. That means that there are no mistakes in the steps. Or if there are mistakes, it should be 1, 3, or 5. Okay, so let's go through his work and see where the mistake is. So we'll start with the given n plus 8 times n plus 20 equals 110. The next step is we need to distribute, right? So distribute 8 to these two quantities right here. So we're going to have n plus 8n plus 160 equals 110, okay? Is that what we have? 8 plus 8n plus, 20. That is wrong. Supposed to be 160 because 8 times 20 is 160. So guess what? Stan made a mistake in step 1. Step 1 has a mistake. Okay? So our answer for this one is B. Alright? Okay. Now moving along. Let's move along to question 25. Question 25 says that when is the statement true? The opposite of a number is less than the original number. So what is opposite? What does opposite of a number do? So the good way to look at this is think about your number line. Whenever you're on the number line and you take the opposite of a number, a flip happens. So let's say this is 0. 0 is right at the center, okay? If I have -1 here, and I take the opposite of -1, guess what? It takes me to the right. It takes me to 1. Okay? So what the opposite does is it takes you to the other side of the number line. Okay? So that's what opposite does. So basically, opposite is a reflection side to side on the number line. All right? So when you get reflected to the left, it becomes less. When you get reflected to the right, it becomes more or greater. Okay? It becomes greater. Okay? If a number is positive and you take the opposite, guess what happens? It becomes negative, which makes it less. Okay, if a number is negative and you take the opposite, guess what? It becomes greater. All right, for example, let's look at -3. If I take the opposite of -3, I end up with 3. Guess what? -3 is less than 3. Because when I took the opposite of this, it became greater. All right? So that's the whole idea of opposites. You're reflecting yourself on the number line, okay? Depending on where you start from. All right? These are, so on this side, these are negative numbers, and on the right side, we have positive numbers, okay? Positive numbers. All right, so for A, the statement is never true. Is the statement never true? Is the opposite of a number less than the original number? It's true sometimes, right? Because if you have a positive number, the opposite is always less, right? So if I have 4, what's the opposite of 4? -4, right? And this is less than that, right? So the opposite of this is less than this. So A is wrong. A is incorrect. All right, how about B? The statement is always true. Is it always true? If you take the opposite of a number, does it always become less? What if we have a negative number? If we take the opposite, it's going to become greater, right? Because a reflection to the right makes a number bigger, right? So let's say we have -3. If I take the opposite of -3, I get 3. And this is greater. Okay? So the opposite of -3 is greater than 3. So the statement is not always true. So B is wrong. C. The statement is true for positive numbers. So if I take the opposite of a positive number, do I get a smaller number? Is that the case? If you pick a positive number, you're going to the right side of it equal to, let's say you have 5. What is the opposite of 5? -5. This is when positive numbers are reflected, they go to the left side. And the left side reflection makes the number less. Because on the number line to the left is getting less, and to the right is getting greater. Okay? So when you're on the right side of the 0 and you take the opposite of a positive number, it's going to become less. Okay, so the answer is C. And then D, the statement is true for negative numbers. Absolutely not, because when you have a negative number like negative 7, when you take the opposite, there's a reflection to the right side of the number line, which is greater, right? 7 is greater than negative 7, and that is not consistent with this remark. So the answer to this question is, the statement is true for positive numbers, because the opposite of a positive number makes it smaller because it's going to the left side of the number line or the left side of 0. All right, so the answer to this is C. Okay, now let's move on to the next number, number 26. All right, so 26 says, what is the y-intercept of the graph 4x plus 2y equals 0? So what again is y-intercept? Well, y-intercept, the graph intercepts the y-axis when x is 0. Okay? That's what the y-intercept is. When x cuts the y, when x is 0. Okay? Because when x is 0, you're right on the y-axis. Okay, but when x starts getting a value, then it starts to move away from the y-axis. Okay, so y-intercept basically means x is 0. All right, so don't forget. So let's say 4x plus 2y equals 12. If I make x 0, whatever y value I get, that is my y-intercept. Okay, so since we have the y-intercept, we have to set x equal to 0. Okay, so we're going to have 4 times 0 plus 2y equals 12. When I solve this equation for y, that would be my y-intercept. Okay, so 4 times 0 is 0. 0 plus 2y equals 12. So we can just drop 0 away. So 2y equals 12. Divide both sides by 2. Y equals 6. And that's your final answer. So the answer is C. Okay. This is a number, this is the y value when x is 0, or basically this is your y-intercept. Okay, so don't forget, y-intercept, x equals 0. Also, x-intercept basically means that y is what? Y is 0. Okay, so in order to intercept one axis, the other axis must go to 0. All right, with that in mind, we're going to move on to question number 27. It says, which inequality is shown on the graph below? Okay, so one thing you have to remember is how to shade in solid or broken. Anytime you have less than, this one basically means that you're going to be shading down, right? And the line is going to be broken. If you have less than or equal to, guess what? You're still going to be shading down because less than means down, but this is going to be solid because this line here means that the solution set includes the line that we're graphing, okay? And then the opposite, greater than, means you're going to shade up, and the line is going to be broken. There's no inclusion here, so the solution set does not include the line. Alright, so the line has to be dotted or broken. Greater than or equal to means that the solution set is above the line, and it's solid because the solution set also includes points on the line, so the line has to be solid to indicate inclusion. Okay, so with that in mind, let's take a look at these ones right here. The graph is shaded above. Okay, it's shaded upwards. So that basically means that it has to be greater, right? It has to be greater. So we have A. A is less than. That can be the answer because less than means you have to shade down, and down is not shaded here. B. B is a candidate, right? No, B is not a candidate because it's less than, so scrap that one. C is a potential candidate because it's greater than, right? Y is greater than 1/2 x minus 1. This is a candidate because it's shading the right direction, because remember, greater than means shade up. D is also a potential candidate because it also has greater than. Now, this line is clearly a solid line, it's not dotted, right? So which is the answer out of these two? Since this has no line under it, it's dotted. So it cannot be this. The answer must be D because it's solid and it's shading up. So this one is solid, shade up. Okay, that's exactly what we talked about here. Greater than or equal to means solid and shade up. Okay, so that's basically that. All right, let's move on to the next question. Question 28. Okay, so it says, which best represents the graph? This graph right here. So basically, we have the graph in slope-intercept form, right? Slope-intercept form is y equals mx plus b. M is the slope, right? And b is the y. Oopsie. I'm gonna write that. M is the slope, and b is the y-intercept. Okay. M is the slope. B is the y-intercept. So don't forget that. Okay. So if we have y equals 2x minus 2, the slope is the coefficient of x. So m in this case is 2. You can write it as 2 over 1. What on earth does this mean? This means you rise 2 and you run 1, starting from the y-intercept. So what is the y-intercept? B is negative 2. Okay, this is your y-intercept. So remember, rise over run for slope, and this is your y-intercept. Okay, so which graph starts from negative 2 and then goes up 2 and over 1? Let's see. Oh wait, the A starts from negative 2, so it's a potential candidate. B starts from negative 2, has a y-intercept. You see this point right here? Let me make it a little bit bigger so you can see. You see this point right here? Negative 2, y-intercept, excellent. Actually, that's C. My bad. Anyway, B has 2 as the y-intercept. So B is bad because the y-intercept is 2. We need a y-intercept of negative 2. So how about C? C has a y-intercept of negative 2. C is a good candidate. How about D? D has a y-intercept of 2, which is bad. You need a y-intercept of negative 2. So let's look at, the answer is either A or B. I mean A or C. Since we have a positive slope, that means the line has to be going up to the right. The roller coaster has to be going up, right? So which of these lines is going up? See this one, you go up 2 over 1, that falls perfectly on the line. But this one, you go to the right and then down. This is a negative line slope. So line A has a slope of 2 over 1. Line C has a slope of negative 2 over 1, because you have to drop 2, 1, 2, and go over 1 to get to the other line. So our answer is A, because that has a positive slope going to the right, and C has a wrong slope going to the right. So the answer is A. Alright, let's move on to the next question. Question number 29. This one is similar to the one we did before, but it requires some work. So for this one, basically we have to put them in slope-intercept form. You see this line right here? Since it's solid, it has to have that line under the inequality. And then since it's shaded down, this one is solid, shade down. That means our inequality must be less than for shade down. Solid means it must be this. Okay, so it has to be y less than or equal to mx plus b. This has to be the formulation of our result. Okay, so if we have a line with a different set of inequalities, that is not a solution set. All right. Another thing to keep in mind here is that for this line, m is drop down 2, 1, 2. You have a negative rise of negative 2, and your run is, I'm sorry, you drop down 1, 2, 3. Your rise is negative 3. Starting from 2, so you go down 1, 2, 3, and then you go over 1. So run 1. So your slope is basically negative 3. Starting from your y-intercept, b, which is 2. Okay, this is your y-intercept. So the equation of the line considering this inequality should be y as less than or equal to negative 3x plus 2. Okay, if you take the negative 3 and plug it in for m, and then you take the 2, I'm sorry, and plug it in for b, you're going to end up with this equation right here. Y is less than or equal to negative 3x plus 2. Well, if we take a look at all these options right here, they have x and the y in on the left side. It's basically in standard form. So let's put this in standard form and see which one it matches. Okay, so I'll to get this in standard form, all the variables has to be on the right. So I'll add 3x to both sides. So add 3x, add 3x. So add 3x here and add 3x here. So that gives me y. Oh wait, let's write it like this. That gives me 3x plus y is less than or equal to 2, right? Because these two cancel out. So do we have a match? Voila, A is a match. Okay, so the answer to this one is A. Alright? Alright, let's move on to number 30. Number 30, it says, which equation best represents the graph above? So let's take a look at that. So all these equations are in slope-intercept form. If we look at this line right here, this line that's been graphed, if we find the slope and the y-intercept, we can plug it into the equation y equals m x plus b, and that will tell us what the equation is, right? So let's start with m first, right? We know what m is. M is a slope, basically rise over run, right? So we can start from any point. Why don't we start from the y-intercept, which is 0? So from here, how can we get to the line? We gotta rise 1, 2, and run 1. 1, 2 for the rise, run 1. So rise is 2, run is 1, which reduces to 2. So the slope is 2. Okay? What is the y? B is the y-intercept, right? Where the graph intersects the y-axis. The y-intercept. So where does it cut the y-axis? It cuts the y-axis right here. So your y-intercept is basically 0. So if we pull in these two ingredients and plug it into the slope-intercept form equation, this is the slope-intercept form. If we plug it into this form, we're going to have y equals 2x plus 0. Okay? Plus 0. And then you can simplify this a little bit further. Since you add in 0, you're not adding anything. So you're just going to have y equals 2x. Okay? And that's your answer. So which of this matches that? Your answer is B. Okay, so there goes your answer. Y equals 2x. Alright, let's move along to question number 31. 31 says, which equation represents the line shown in the graph below? This one's just like the other one. Y equals mx plus b question also. Okay, so can we decipher m and b from the graph and substitute it into this equation and generate one of these options? If we can, then that will basically be what our answer is. Okay, so let's take a look at this graph. Let's do b first this time. Okay, so b is a y-intercept. Where the graph intercepts the y-axis, where does that happen? It happens at 4. So your y-intercept is 4. M is your slope. Your rise over run starting from any point on the graph to another point on the graph. How about we start from our y-intercept 4? How can we get back to this line? By rising and running. So we get to rise 1, 2, and run 1, 2, 3. So rise 1, 2, and run 1, 2, 3. That gives us a perfect point that's on the line. Okay, so our rise is going to be use blue. So M is basically rise over run. Rise over run. Starting from the y-intercept, we rose 1, 2, and we ran 1, 2, 3. So yeah, the slope is 2 over 3. So our answer, we substitute the m for the m right here, and then we substitute 4 for b. We're going to have y equals 2 over 3 x plus 4. That's our answer. Which one matches? Our math right here is A. Okay, so that goes your answer. Alright, let's move on to number 32. 32 says, what is the x-intercept of the line defined by negative 2x plus 3y equals 12? What is the y-intercept of this? Remember what x-intercept means, right? X-intercept is where the graph cuts the x-axis. In order for the graph to cut the x-axis, y has to be equal to 0, or else the point is going to be away from the x, okay? So all we just have to do is make y 0, solve for x, that will be our x-intercept. So we're going to have negative 2x plus 3 times 0 equals 12. Okay, so we're going to have negative 2x equals 12, because this 3 times 0 eliminated this one. This whole thing just goes to 0, and you can drop it off. To get x by itself, divide both sides by what? Negative 2. Okay, not just 2, negative 2. So you're going to end up with x equals negative 6, and there goes your final answer. Negative 6 is D. So the answer to this, to number 32, is D. Alright, now let's move on to the next question. Question number 33. It says, which point lies on the line defined by 3x plus 6y equals 0? So which of these points lie on this line? This line, the line defined by 3x plus 6y equals 2. If a point lies on it, that means that it has to satisfy this equation, or else it doesn't lie on it. What does that mean? Basically, you plug and chug, just plug in the values and see if it works, okay? So let's start with A. We have 0, 2. What does that mean? It means that x is 0 and y is 2. If I plug in these two, does it satisfy this equation? If it does, then it's the answer. If it doesn't, we move on to the next one, okay? So let's write this one. 3 times 0, substitute 0 for x, plus 6 times 2, substitute 2 for y. Is it equal to 2? I'm going to put a question mark here, because I don't know if it's true or false, okay? So this one just becomes 0. Don't forget about this. It's just 0. Is 12 equal to 2? That's false. So A is not an answer. Let's try B. 0, 6. X is 0, 6 is y. If I plug it in here, is it true or false? Is 3 times 0 plus 6 times 6, is it equal to 2? This one is going to go to 0. Question is 36 equal to? Absolutely not. So this is false also. So the answer is not, B is not an answer. Alright, C, 1 comma negative 1 6. This is your x and this is your y. The question is 3 times 1 plus 6 times negative 1 over 6, is it equal to 2? Is it? 3 times 1 is just 3, but this side right here is a little bit complicated, so how do we do it? How about we write this as a fraction, okay? If we write this as a fraction, we're going to multiply across, okay? Plus times minus, signs are different, so when you multiply numbers with different signs, the sign is always a minus. 6 times 1 is 6 over 6, because 6 times 1, you just multiply across, okay? Equals 2. Is it? Well, let's simplify this monstrosity on the left side and see what we get. So 6 divided by 6 is 1. Is 3 minus 2 equals 1? I mean, it's 3 minus... switch it around. Is 3 minus 1 equals 2? Absolutely, right? 2 equals 2. Perfect. This is the right answer. The answer is C. Because the ordered pair 1 comma negative 6 satisfies this equation, alright? Okay, now let's move on to 34. It says, what is the equation of the line that has slope of 4 and passes through the point 3 and negative 10? So there are two methods I'm going to show you for this one. So whichever method you like, you may apply. The one you're familiar with, the one you were taught. So the first method I'm going to use is a point slope equation. Y minus y1 equals mx minus x1. Okay? I'm going to use this point slope equation. Let's call this method 1. This is the quickest method. It's much more advanced and elegant. I prefer this method. But there's a more elementary method that we can also employ. Okay, so let's use this one. So this one, all you need is the slope and a point. In the question, the slope is 4, and the point x1, y1. The point, I have to write it, x1, y1 is basically 3 comma negative 10. So all you do is put this information in here, get y by itself, and whichever match you have is your answer, okay? So we're going to go y minus y1 is the y coordinate that's given, which is negative 10. Please use a parenthesis whenever you're substituting, especially if it's a negative number, okay? M is 4 times x minus 3, okay? If we simplify that, we're going to get y plus 10 equals 4x minus 12. All right? Now we're going to subtract 10 from both sides. To get y by itself, subtract 10, and then you're going to have y equals 4x minus 22. Okay, so your match here is A. So our answer here is A. Okay, this is using the advanced method of the point slope form. Okay, this is the point slope form. Now there's another option you can use. Methods. This is method 1. Method 2 involves using the slope-intercept form. Okay, this is much more elementary, but it doesn't require you learning a new formula or remembering this point slope equation. Okay, so if you don't remember the point slope equation, just use method 2. Okay, method 2 requires the use of y equals mx plus b. You already know that m is 4, but you have to find b. So now to find b, you just have to use the idea that xy is equal to 3 negative 10. We're going to plug in these values here. So for b, and then we substitute b and m into this equation for a final answer. Okay, so we need to find b. Okay, how do we find b? Let's plug it in. We're going to plug in negative 10 for y, negative 10 for y equals m, which is 4 times x3 plus b. Okay, and then we're going to have negative 10 equals 12 plus b. Subtract 12 from both sides, subtract 12, subtract 12. And then you're going to have the result b equals negative 22, because when the signs are the same, you add and keep the sign, all right? So I now know that m is 4 and b equals negative 22. So guess what? I'm going to plug it into the slope-intercept form equation, y equals mx plus b. When I do that, that's going to give me the result y equals 4x minus 22. All right? So there goes your final answer. All right, so which one matches with that? We already know that it's A, right? So that's it. Whichever method you like, you can use. I prefer method 1 because it's quicker and much more elegant, but you need to know this formula. If you don't know the formula, then you can just use y equals mx plus b method to do the same process. Okay, now let's move on to question number 35. Question 35. It says the data on the table shows the cost of renting a bicycle by the hour, including the deposit. If hours H were graphed on the horizontal axis and costs C were graphed on the vertical axis, what would be the equation of the line that fits the data? Let's see. So for this one, there are 2 ways we can do this. Actually, there are 3 ways. Let's start with writing them as points. Okay, so I can write this, the first ordered pair 2 and 15 as 2 comma 15, and then I can write the next point as 5 comma 30. Okay, so if I can find m and b, then I can basically write out the equation of the line. Okay, so how do we find m to begin with in this problem? To find m, I'm going to call this x1, y1, and I'm going to call this x2, y2. To find m, you're going to do y2 minus y1 all over x2 minus x1. Okay? So y2 is 30 minus y1, which is 15, divided by x2, which is 5, minus x1, which is 2. Alright, when you do the math, you're going to end up with 15 over 3, which is 5. So our m equals 5. Okay? Guess what? With m equals 5 and any of the points, placing the point 2, 15 as x1, y1, I can find the equation of the line using the method 1 I just showed you earlier. Okay? So I can also use method 2 if I want it. All I need is a point and a line. All I need is a point on the slope, and then I can write an equation, okay? So let's use method 1. Method 1, we have the point slope form, y minus y1 equals m x minus x1, okay? Remember, this is x1, y1, and that's m right there. So I'm going to plug all of this into my equation. So we're going to have y minus y1, which is 15, equals 5 times x minus x1, which is 2. Let's get y by itself, and we can see which one matches with this one, okay? So we're going to have y minus 15 equals, if I distribute 5 to both of these, I'm going to have y equals 5x minus 10. And then add 15 to both sides. And I'm going to have y equals 5x plus 5. Okay? So in this problem, what we're going to do is just adjust the variables, okay? C will be, this is x, the independent always comes first, right? And the dependent comes second. So this is x and this is y. So we can just write x as y as c, so c equals 5h plus 5. Okay, so which one matches? C. The answer here is C. Okay, so this is C. Alright, so that's using method 1. If we wanted to use method 2, let me do that on the side right here. For method 2, what we need, basically, we need M and B. We want to use Y, wrong color. For method 2, put them lower. Method 2, we want to use Y equals MX plus B, right? We know that M is 5, as we found out before, and we have a point XY that is 215. Okay? So we're going to use this to find M and B. So to do that, we just plug these two into this equation. This is X and this is Y. So 15 equals 5 times 2 plus B. Alright, solve this for B. So we have 15 equals 10 plus B. Subtract 10 from both sides, and then you have 5 equals B. B equals 5, and M is also equal 5. So we plug in these two into the slope-intercept form, y equals mx plus b. And that gives us y equals what? 5x plus 5. And there goes your final answer, which is the same as what we got before, which is C. Okay? So just make the adjustment, and that will be that. Alright, let's move along to number 36. 36 is just like what we just did. It says some ordered pairs of a linear function function of x are given in the table below. Which of the following was used to generate the table above? Okay, so basically, which of these equations can be used to generate this? All right. All right. So for 36, I'm going to show. There are actually 3 ways of doing this. I'm going to show you the slope-intercept point slope form first, and then I'm going to show you another trick you can use, a shortcut. Okay. So if I wanted to use the point slope form to write down the equation of the line, I can just write down the first 2 points as 1, 1, and the second one as 3, 7. This is going to be x1, y1, and this is going to be x2, y2. And then first of all, we need to find the slope, right? So m is going to be y2 minus y1 over x2 minus x1, right? So it's going to become 7 minus 1 over 3 minus 1. That gives us 6 over 2, which is 3. So our slope here is basically 3. M equals 3. So without even doing anything, if you look at your options right here, you can see that the only equation with slope of 3 is C. So we don't even need to do any work. We know that our answer is automatically C. Another way you can do it is by using a test. You pick up a pair and check to see if it works, okay? I don't like the first and second one. I like to go down. Let me pick up 5, 13, okay? Because the first few ones are normally tricksies, okay? They normally trick you. So I don't want to try these two. Let me pick 5, 13, okay? If 5, 13 works for more than one, then I will move to another one, okay? So let's test 5, 13. I'm going to plug in x, 5 for x and 13 for y. In all these equations, the one that works out is the answer, okay? So this is method 2 that I'm using here. This is another method of doing the same problem, okay? So I'm going to test A. A is y equals 2x plus 1. So I'm going to ask myself, is 13 equals 2 times 5 plus 1? Is it? Is 13 equals 10 plus 1? 10 plus 1 is 11, so A is wrong. Uh-oh, what did I just do? So A is wrong, okay? All right, B. I'm going to test y equals 2x minus 1. So the question is, if I plug in this ordered pair 13, 5, Is it going to work? Is 13 equals 2 times 5 minus 1? Is 13 equals 10 minus 1? 10 minus 1 is 9. 13 is not equal 9. So B is not the answer. So let's try C. C is y equals 3x minus 2. This better work because that's what we got before, right? So the question is 13 equals 3 times 5 minus 2, is it? Is 13 equals 15 minus 2? Is 13 equal 13? Absolutely. So our answer is C. Okay, so you can do it using point slope form, and then it turns out that that's the final answer. We just got that by being smart. Or you can do a test. Just pick a point, pick points, and plug it in and see which ordered pair which equation satisfies the ordered pair. Okay? So there you go. So answer 36 is C. Alright, let's move on to question number 37. It says, which point lies on the line represented by the equation below? So for this one, 37, we have 5x plus 4y equals 22. So which one is going to work? So let's start with A. We're going to test all of them, right? So let's start with A. Negative 2 and 11 over 4. So this is x and this is y. If I plug it in, does it satisfy? If it does, that's the answer. Alright? So let's do the test. 5 times negative 2 plus 4 times 11 over 4. Is that equal to 22? Is it? Question mark. This 5 times negative 2 is negative 10 plus, if you multiply this across, you can make this over 1. 44 over 4. Is it equal to 22? Is negative 10 plus 11 equal 22? Because 44 over 4 is 11, right? Negative 10 plus 11 is positive 1. Is positive 1 equal 22? Nope. A is wrong. Let's try B. So B, we have negative 1 and 17 over 4. I want to plug it into the equation. 5x plus 4y equals 22. So the question is 5 times negative 1 plus 4 times 17 over 4. Is it equal to 22? Is it? Is negative 5 plus 4 times 17 is 28 plus 40, which is 68. The 68 over 4 equals 22. Well, I could have just canceled those. I could have just canceled these two to get 17. But that's fine. So we're going to have negative 5. Is negative 5 plus 17 equal 22? Negative 5 plus 17 is 12. Is 12 equal 22? The answer is no. So B is not an option. It's not the answer. Okay? Alright, let's take a look at C. 2, 3. Plug it in into 5x plus 4y equals 22. So it's 5 times 2 plus 4 times 3. Is it equal to 22? It's 10 plus 12 equal 22. Or the question is 22 equal 22? Absolutely, right? So our answer is C. Okay? So there you have it. So this is basically like a plug and chug type situation. Alright, now let's move on to question number 38. Question 38. It says, the equation of the line L, 6x plus 5y equals 3, and the equation of the line Q, 5x minus 6y equals 0. Which statement about the two lines is true? So, we have L. L is 6x plus 5y equals 3. Let me put this in slope-intercept form first, okay? That's the best thing. So I want to put this in this form, y equals mx plus b, because this form makes explicit the slope and the y-intercept. I don't know what the y-intercept is or all that stuff. So let's put this in this form. So I'll subtract 6x from both sides first. That gives me 5y equals negative 6x plus 3. And divide everything by 5. So you're going to have y equals negative 6 over 5, x plus 3 over 5. Now this is a slope-intercept form for L. Okay? And then let's do Q. So Q, we have 5x minus 6y equals 0. Subtract 5x from both sides. That leaves us with negative 6y equals negative 5x. And divide both sides by negative 6, so you can get y by itself. So you're going to have y equals minus over minus is plus, right? 5 over 6x. Okay? So this is line Q. Both of them have now been placed in the same form for easy comparison, okay? So first question, do they have the same y-intercept? So for A, are their b's the same? B the same. Do they have the same b? Let's look. For the first one, b is 3 over 5. This one, the b is 0, so no. These are different. B, lines are parallel. Parallel basically means that the m of L is equal to the m of Q. The slope of line L is the same as the slope of line Q. The m of L is negative 6 over 5. Is that equal to the m of Q, which is 5 over 6? Are they the same? No. False. So B is not the answer. They are not parallel because their slopes are different. C, L and Q have the same x-intercept. X-intercept basically means that if I set y to 0, will I get the same answer? Okay, so let's set it up. So let's look at line L. So for line L, if I set this to 0, I'm going to have 0 equals negative 6 over 5x plus 3 over 5. That's to find the x-intercept. We're testing C now. If I want to get x by itself here, but let's pause and just take a look, okay? So this is what I have for this, and this is for L. And then for Q, if I set y to 0, I have 0 equals 5 over 6x. Just by looking at these two equations, do you think that when you solve them, you're going to have the same answer? Absolutely not, right? Because this one is going to be 0, and this one is going to have a number other than 0 in it. Because if I times this one by 6 over 5, for example, both sides, 6 over 5, I'm going to have 0 equals x, right? But this one is going to be slightly different from that, because this one I subtract 3 over 5, I'll have negative 3 over 5 equals negative 6 over 5x. And then to get rid of this x, I times by negative 5 over 6. And then this one I times by negative 5 over 6. That cancels with that. That cancels with that. So you're going to have x equals, this one is going to be 5 cancels with 5. So when we times that, it's going to be 3 over 6, which is 1/2, right? Clearly they're different. This is 0 and this is 1/2. So C is absolutely not a choice. How about D? D says they are perpendicular. What does perpendicular mean? Perpendicular basically means that one is the inverse of the other. So basically, the perpendicular is m of L equals the negative reciprocal of m of Q. So if I start with m of L, the slope of line L is negative 6 over 5. If I do the negative reciprocal of the slope of Q, which is 5 over 6, do I get this? Are these two the same? Absolutely, right? Because this reciprocal just means I flip this, and you're going to have negative 6 over 5 equals negative 6 over 5. Because the reciprocal just basically means that this goes to the bottom, and that goes to the top. Another way you can do this is you're going to have negative 6 over 5 equals negative 1 times the reciprocal of 5 over 6, which is 6 over 5. Because division is the same thing as multiplying by the reciprocal, right? And then when you times this out, you get negative 6 over 5, which is the same. So that means that these two lines, this implies that L is perpendicular to Q. Okay, so they are perpendicular, so the answer is D. Alright, now let's move on to question 39. It says, which equation represents a line that is parallel to the given line? You're given, in 39, you're given the line y equals negative 5 over 4x plus 2. If two lines are parallel, that basically means that let's call this line 1. The m of the first line is equal to the slope of the second line, right? So what is the slope of this line? The slope of this line is the coefficient of x, right? Because y equals mx plus b. the coefficient of x, or whatever number you're multiplying x by, that is your slope. Okay, so the slope of this line is negative 5 over 4, right? Because that's what we're multiplying x by. So for option A, what is the slope? What is the slope of option A? The slope is the coefficient of x, which is negative 5 over 4. Is that the same as the slope of this line? Negative 5 over 4? Is that the same? Absolutely is. They are both the same, right? So this matches with that, so our answer is A. Okay? Alright. Now, let's move on to question number 40. Question 40. Question 40, we have, it says, which graph best represents the solution to this equation right here? So what we're going to do is basically take a look at these two lines and place them in a slope-intercept form. Okay, so we have 2x is greater than or equal to y minus 1. So I want to place this in slope-intercept form. So for this one, I'll add 1 to both sides, and I'm going to have 2x plus 1 is greater than or equal to y. If I switch this around, note that the inequality is pointing to the y. So if I put the y first, the inequality keeps pointing to the y, okay? Y is less than or equal to 2x plus 1 is the same thing as 2x plus 1 is greater than or equal to y. Okay? So for the second line, we have 2x minus 5y is less than or equal to 10. Subtract 2x from both sides. And then we're going to have negative 5y is less than or equal to negative 2x plus 10. Divide everything by negative 5 to get y by itself, right? So divide by negative 5, and negative 5. And then you're going to have y. Now note, anytime you divide by negative, the inequality switches to greater than or equal to. Okay, greater than or equal to 2 over 5x. Because minus over minus is plus. Minus over plus is minus. Anytime you divide the same signs, you always get a plus. When you divide different signs, you have a minus 2. Okay? Now, this basically means that the line where the y-intercept is 1, less than basically means you're going to shade down. Okay? And then the line where the y-intercept is negative 2, you're going to shade up, or your arrow is going to be pointing up. Okay? So let's take a look at that in this problem. So if you take a look at number 1, so for this one, I'm going to put this in a different program. Let me pause this. Alright, so I just grabbed it into this program. So basically, if you look at what we have, all the lines here, all the lines have y-intercept as 1 and negative 2. So y-intercept is negative 1 for the first line and negative 2 for the second line. 1, negative 2, 1, negative 2, 1, negative 2, 1, negative 2. So all these graphs are basically similar, okay, because they also have the same slope. So what's the only thing that's different is where they're shaded. So this is a shading problem. This question is testing your understanding of shading, okay? So for the one line, this is a one line right here. This one, this one, this one, this one. One line means shading goes down. So you're supposed to shade this direction, downwards. Okay? Shading goes down. Okay, like that for the first line. You shade downwards under the line, okay? Like under the roof. And then for the negative 2 line, the shading goes up. So it's going to look for, this is a line with a negative 2 as a y-intercept. So the shading goes up here, up here, up here, up here, up here, up here. Okay. So looking at the arrows, which area is correctly shaded? The quadrant where you have 2 arrows pointing to, and that is the area that's shaded, that's the correct answer, okay? So here you have 2 arrows pointing here. This is supposed to be your solution set, but this is where it's getting shaded. This is wrong because you're shading behind the line and the arrow says go down. So the answer cannot be A. But let's look at B. The 2 arrows are pointing to this quadrant, the first quadrant in this lantern coordinate system. This is your answer right here, okay? If you look at this, it says shade here, but this is going behind the 2 arrows, so that's not an answer. If you look here, as they were pointing here, it's nowhere it's shaded. This shading is wrong because you're going behind this arrow. This arrow says shade up or greater than, and you're shading down, so this is wrong. So your answer to number 40 is basically C, okay? Because all the graphs are the same, the focus here is just on where to shade. Okay, so thanks for paying attention to this clip. Do subscribe to my videos. I'm going to be preparing the remaining 2 clips. Hopefully this can help you do well on the exams. Okay.